In this video, we'll be covering the basics of sets and Venn diagrams. So, what is a set? A set is simply a collection of objects. In the examples I have here, I have the sets C and N. C is just a set that is a collection of different types of animals. So we have cat, dog, turtle, dolphin. Those are the objects within set C. Let's look at set N. Within set N, we just have numbers from 1 to 5. So we have 1, 2, 3, 4, and 5. So that's really all a set is. It's a collection of objects. So where does a Venn diagram fit into all of that? Well, a Venn diagram is a diagram that shows the relationship between sets. And we're going to focus in on that relationship part. So we're showing the relationship between sets. So here I have an example of what a Venn diagram looks like, and let's just dissect this so we can get to understand exactly what this is saying. So on this Venn diagram, we have a couple of elements. We see the letter A, B, and this funny looking E character. So what do these all represent? A and B, they represent sets. So A represents the set of all the elements that's within this circle, right? And B represents all the elements that's within this circle. I know my circles are really badly drawn, but hey, that's what they represent. So what does this E character represent? So E, well, we might not even call it E, because sometimes you might just see it as a U. So this, regardless of whatever you call it, this represents the universal set. So we'll just write it here, universal set. So that's going to be all of the elements, every single element that's within this large green rectangle that we have here. So that means that E, or U, that represents the universal set. So that contains A, B, and everything that's not in A and B. Hopefully these scribbles illustrate that to you. So if we just kind of take things back a little bit. So if E is a universal set, A and B are just sets within E. And that's really all that there is to Venn diagrams. Now let's go down, let's start talking more about this relationship aspect. So if you've ever taken a class that covered Venn diagrams, you might have seen some of this set notation that we talk about. So in this first example here, we have A, and then we have a funny looking character that kind of looks like a U, and then we have B. So this character, we can read this as union. So when we see A and this character B, we can just say it as A union B. That's how we would read it, A union B. So what A union B actually means is we're looking at all the elements that are in both A and B. So if I was to shade the region that represented A union B, it would look like this. It would look like everything within A and B, right? So that's A union B, all of the elements that are encompassed in both A and B. So let's look at intersection. So intersection can be a little tricky sometimes. So we have this character here, which looks like an upside down U, or you can say that it looks like an N. That's how I look at it. It looks like an N. So N, intersection. You know, you could draw some relation there to kind of remember things. So we would read this as A intersection B, similar to how we read this as A union B, right? So what this means is we're looking at all the elements that are shared between A and B. So that would have to be this region here if we were going to shade it. Because when you look at it, we have some of the elements in A matching with some of the elements in B, and that's going to give us that intersection there. So that's really what intersection means. We're looking at elements that are in both A and B, that are shared between A and B. So in union, we're looking at elements that are encompassed in A, in just A alone, in just B alone, and we're looking at the intersection. So if you look at it, we have those three regions. Let me make that a little more clear to you. So we have three regions, right? We have region 1, region 2, and region 3, right? So we just spoke about this region. This is the intersection. And then this region here, region 3, this is just the region of elements that are in B and in B alone. Region 1, these are just elements that are in A and only A. So the union would be all of these regions combined. Whereas here, the intersection would simply be the elements that are shared between both A and B. So I hope that's clear to you. So let's move on to another piece of notation. And this is the complement. So the complement is basically saying we're going to look at A. And when I say complement, I mean this apostrophe looking symbol right there. So when we say complement, we really mean all of the elements that are not in A. So if I see A complement, that means that I'm looking at literally everything within this rectangle other than elements in A. So if I was to shade that region, here's how that would look. So we would shade it, and we're not going to touch the A circle. We're going to touch everything other than the A circle. Even up here. Even some of the B circle, but nothing in the A circle. And that's going to be the A complement. Everything that is not within A. So let's look at B complement. So B complement works basically the same. So it's going to be everything that is not within the B set. So we're going to shade everything except, whoops, see this kind of, these two touching the B. So yeah, it's basically going to be everything that is not inside of B, including the region that's just encompassed by this bounding box here, right? So that's going to be B complement. So we just zoom out and take a look at everything. We have the union, which represents the region of all the elements in A, in both the intersection of A and B, in just A, and in just B. That's the union. We're just taking all the elements in both A and B, right? The intersection now is just going to be the elements that are only shared between both A and B, and that's it, right? The intersection is just the elements that are both in A and B. And now the complement, if we have A complement, that's just simply describing all of the elements that are outside of A, and for the B complement, all the elements that are outside of B. So let's look at examples that combine these. So let's look at these two examples here. So this first example has A union B, and then we have a complement here. So basically how we would read this, as A union B complement. So remember before, we said that A union B is going to be everything in both A and B. Everything in both A and B, right? And we also said that if we're talking about the complement really just means if whatever's in these brackets, we're looking at everything outside of that. So that means our complement would have to be everything in red. Because if we're looking at A union B, that means the complement is going to be everything outside of A union B. And this red region is really what this set here is describing. It's describing the red region. So let me just erase these black lines. So if we look at it, all this is saying is telling us we're going to look at A union B, and now we're going to shade everything outside of A union B. And that's how you evaluate a statement like that. So everything that is not within A union B. That's what this relationship is describing here. So let's look at another similar example to this. So we have A intersection B complement. So again, I'm going to use black. So black is going to represent the elements. Well, black is going to represent the expression within the parentheses, right? So we have A intersection B. So we're looking at elements that are both in A and B. So that's going to be this region right here, right? So that's A intersection B. But now we're looking at the complement of A intersection B. So what does that mean? Anything that's within those brackets, we're looking at literally everything else other than what's in that bracket. So we're looking at some of this region of A over here, some of this region of B over here, and the region outside of both A and B. So if I was to shade this, we would exclude this intersection region. Oops. Let me undo that. We would exclude this intersection region right here. And that would be it. And that's how you evaluate a more complicated, well, I wouldn't even say complicated, but this is just us combining the set notation. So that's the basics of sets and set notation. Now, what I want to show you is some other Venn diagrams that you might come across. So remember, a Venn diagram just shows the relationship between sets. So I can have a Venn diagram that's literally just one set. It'll just be the set A. Or I can have a Venn diagram with two sets, A and B, and they might not have any relationship between them. There's no overlap. They're just two sets chilling in a universal set. And remember, the universal set is represented by this symbol here. So there's no relationship between them, and that's okay. That's a Venn diagram. We just have two sets, and we're putting all the elements in these circles. Now you might have seen something like this, where you have three circles. So for this example, we have three sets A, B, and C, and now we're showing relationships between the three of them. So if we look at it, let's look at this region here. This region is just describing the relationship between set C and set B, right? Because we have overlap between just C and just B. If you look at how the circles lie, right? All of this here, this region here, this is only overlapped by C and B, right? And similarly, you can look at that with all of the other intersections. So for example, this region here shows the relationship between just between just A and B, because this region is only concerned with A and B. Similarly with this region, we have a region here which shows a relationship between just A and C. And now in this middle region, we have a relationship between A, B, and C. And you could basically just draw some circles and put in an overlap, and that'll show you the relationship between the two sets that you're representing. I can even have a configuration where we just have A and B. A and B might have a relationship, but C might not have a relationship to either A or B, right? That's perfectly fine, because these are all just sets. And I might have another Venn diagram that looks like this, where we have B in the center, and B has a relationship with C. B also has a relationship with A, but A and C, they don't have a relationship, right? There's nothing between them. There's no relationship between them other than the fact that maybe C has some elements in B and A has some elements in B, but A and B don't have any elements in common. So you might see these things or you might not, but whenever you look at a Venn diagram, just know we're just looking at sets and the relationships between those sets.